Hey, what's up guys? Welcome back to my channel, and today in this video I'm going to talk about a very important concept in any application development, which is caching. Caching is one tool which you can use to get the best performance out of your application. However, we need to understand that caching is not just one cherry on top which will make everything go fast. Yes, caching needs a lot of thinking and implementation, and you have to be clear about the architecture to get the best benefits out of caching. In this video, I'm going to talk about the three different layers at which we can cache, what are the benefits, when we should use which particular caching strategy, and overall how the architecture will help us implement a good caching mechanism. So if this is something which interests you, let's do a deep dive and understand how to cache our application for the best performance. Now, before I jump into the code, it is important to understand the concept of cache so that we are on the same page. Let's take this example of this page where I have some blog posts and I'm listing them one after the other with a pagination. Now, this application, when gone to production, we will have use cases where users will come in, they will see this list of blog posts, they will click on the README, they see the detail page, maybe they come back and they see one more. Pretty straightforward, right? And it works pretty fast on my machine as well. However, there is a caveat. See, right now, the only user using this application is me, just one user. When this user number increases, we have concurrent users, multiple users using the resources of your server at the same time. Now, believe it or not, in any application, the database will always become the bottleneck because it needs to retrieve information from the stored files, understand that, make the database query, do a lot of things. A lot of magic happens behind the scenes when we run a query. So it will do all of that. Then with the data, framework will get it. It will convert them into models and all the other code will get executed once the data is given to the PHP application from the database. So as you can see, the database plays a key role. And the more number of concurrent users you have, the more stress you are putting on your server. A typical server will have a number of limit in terms of how many processes it can run to give out query results. How many PHP processes I can have to handle the requests. And that's where your server starts to get load and it starts to get slow, right? And in this kind of application, the concept is first in, first out. So the one request which came first ideally needs to be quickly cleared out. However, if the request is waiting for the MySQL result, then one more request comes in and it also waits for the MySQL result, and one more and one more. So this way things pile up and overall every user starts to get a sluggish behavior. Why? Because your server is waiting with the processes to get data. And that's where the cache comes into picture. If my application is able to somehow bypass the database call and quickly get the result data that it is looking for, then I have saved the round trip to the database. And this is how we can use caching. So now that we are clear, let's understand the code on how to implement a cache. So now that the concept is clear to us, let's understand what could have been happening behind the scenes for this particular page. So I am on the syntax page. A query got fired from the controller and it retrieved maybe the latest 15 blog posts from the database and it is showing it. If I click on one, I am using the slug to get the latest one. Sorry, not the latest one, but I'm using the slug to pull the exact blog post because slugs in my database table is unique, and that's how I retrieve it. But as I said, this is all fast when it is on my machine. but when it goes to the production server, multiple users are using it, stress starts to pile up. So how do we save it? That's where the first strategy, which is page level caching, will come into picture. Okay. In this particular thing, if you see this result, these 15 blog posts will continue to be the same till I edit a blog post or I add a blog post. Okay. There's one difficult thing, which is when the cache needs to be defeated, especially when I have created a new blog post, all pages need to be cleared because every page will have a change in this sequence of blog posts. But the blog posts, the write operations versus the read operations, I think you understand that the number of reads is very high compared to the writes. And that's where this page level caching makes sense. Now, how have I done that in this page? Let me go to my blog controller. Now in here, there's a classic example of how we can use repository pattern to interchangeably use different kinds of caches. Laravel allows us to quickly change the driver of our cache, but I wanted to define a different way of caching, and hence in this repository, I have done that. So as you can see, I am on my controller. I have a constructor, and in that constructor, I have injected the blog repository. Then from the blog repository, we can assume, because this interface has said that I need one method, which is get blog posts. I'll pass the page, I'll pass the per page, and in return, I get a length aware paginator. Okay. So my controller, irrespective of the implementation, is saying that, okay, because I have this contract in place, I can call get blog posts and I can get the blogs. And once I have the blogs, well, I can send it to the view and render it. That's pretty straightforward, right? But the magic happens in the get blog posts. How? I'll first show you my app service provider. See, this is my app bind. I have an abstract blog repository. So I'm saying that this is my abstract, and the concrete implementation for it right now is file blog repository. Okay, let's see what we have done in file blog repository. So obviously it implements blog repository and it has defined get blog posts. You can see the signature is same, the return type is same. Now, the first thing that I'm doing is I'm creating the cache key. This is my cache key, blog underscore posts underscore page count, and then per page. Why? Because every page will have a different cache. Okay. So we do that. Then we say that when I'm just logging in, logging that file cache, and then the typical Laravel cache facade is being used. So cache store, remember, this is the key, this is the time. TTL means how much time it will live. After this, the cache will get invalidated, and so we don't need to worry about it. So yes, this is the cache key, this is the TTL, and then in this closure, I am returning the data that the cached key will have. And inside it, obviously, I have one log as well. So whenever we are over here, it means that the cache was missed. Okay. And now there are certain things that we need to understand and kind of, I would say, keep in mind. I have given a TTL, and you can have a high TTL, but it is always a good idea to create TTLs because your Redis and other cache providers do have some, I would say, logic to clear cached objects when the overall memory that you have allocated for cache is kind of getting exhausted. Plus, there can be situations where sometimes the cache invalidation doesn't happen. And if you don't have an automatic cache invalidation TTL, then you are on the mercy of the developer to manually go and clear the cache. Because if the cache is not getting cleared, the user will see stale content, your database has been updated, your cache has not, and that is not something which you want to have in your application. It can have bad side effects. So I always keep a TTL. You can have high, you can have a low one based on your application's data requirements, but yes, keep a TTL. Okay, so this is how I am getting it. And just to prove a point, I have two implementations. One is the file, and the second one obviously is Redis. I am running Redis. You can see that in here, very high level, only one thing has changed, which is the cache store. I have written this code twice because I wanted to show you that if your implementation of cache is a bit different, you don't need to write a driver. This is where the repository pattern will help you. You can have the logic there. You can pull it from anywhere which you feel which is fast enough, and then you can cache it and return to the user. Okay. So let's first run the file cache layer. So I'll go over to my, it's a file level cache. So framework, cache, data, and I'll delete this folder. Okay. And where's my log file? I'll clear this as well and hit refresh. Once I do that, can you see, because I have deleted that folder 91, which has come up again, it happened because first we saw file cache, which is file blog repository. So it came here. Then it saw that this key doesn't exist. So the closure got executed, and that's why we get this log. This query was executed and it was returned. So I see this list of blogs, I see this log, and now let's hit once, twice, 3, 4, 5. And as you can see, I got this file cache, which means it came till here, but the closure never got executed. So this query never ran. And what we basically did was we used this file. And this is how we are saving a round trip to the database. Now the thing is, it's a file system level cache. So unless and until you have a very heavy query, lots of joins, inner queries, things like that, your overall query is taking a lot of time to fetch the data, right? If that is the case, a file system based cache can still work, because MySQL is also storing data in files in your database. It's storing something on the disk. Yes, it is much optimized compared to the normal disks, but it is IO at the end. So if you need to beat the speed of IO, file system cache is not going to work for you. Very good for development, very good where your queries are quite heavy and your MySQL read is maybe longer than what would typically be taken to read a file. Okay, so we can use that. Also, one thing to notice, I just remember, is if you are running your application behind a load balancer, then this kind of caching strategy is not the best, because your cache will have to be created on two different servers. The invalidation rules will be executed in separate ways, so it can create complications. So if it is a single server, file-based system cache, still fine. Otherwise, don't rely on that. So how do we tackle this? That's why I had created the Redis one. So this Redis one is where we connect to a memory-based Redis instance. Those of you who are not aware of Redis, Redis is a memory-based cache layer. It's an application which uses your RAM to store data. And that is why Redis is very fast. Redis is a very simple key value pair. So in this case, this is my key, and towards that key, there is a text which is stored as value. Okay. So if I show you the file system cache, you can expect something like this in your Redis key. Okay. This entire content will be there inside Redis. And because this content is sitting in my RAM, Redis operates on RAM, right? So because it is in RAM, it is very fast. It's like instantaneous. The application boots, it gets to the memory, picks up the information, gives it back. Nothing is as fast as RAM. And hence, Redis can be a very good thing. On many of my applications as well, what typically I do is I will have a database server, I will have an application server, and then I will have a Redis server as well. The Redis server is kind of central. All the application servers will connect to Redis so that the cache store is common. Everyone is hitting it, checking for keys, getting the data, expiring them, all those things happening in one. So I can kind of increase the RAM of that server to quite a good amount, and use the entire memory for performance. So this is how the page level caching works. But let's just say that the page level cache is still fine, but sometimes you can have situations where individual elements or objects are also quite complex and you want to cache them. A great example would be, I have seen with Drupal, when I used to work with Drupal nodes. Okay, in Drupal, every content is called a node. Now, a node can have multiple fields, and each field would be a table in the database, right? Because in Drupal, you can add as many fields. So they had to make a database architecture where every field that you add means there is a new table created. So when you are loading one piece of content with a lot of fields, you get a lot of joined table, right? And sometimes at scale, it can become quite heavy. And what Drupal does is it has page level caching, and it also had node level caching, which means a node will be, once it is created, it will be saved in the database as one object so that it doesn't need to parse through all the tables. And the second type of caching that we are going to see is very similar, which is object level caching, which means, so I have this blog model, and you will see there's a trait, okay, cacheable trait. We'll go into that in some time, but what I am doing is there's a static method called find by slug cached. Where is it being used? Let's go to our controller. I will close to the right, go to the controller. So I get the slug and I run that static method find by slug cached. I pass the slug over here, and then our model has this static function. What does it do? It is getting the cache key for slug. How does it do that? Well, that's where our trait or our concern will come into picture. Okay, we have obviously get cache key. So when we are requested for the object, right, it will first look for this method. It gets the cache prefix. So we will get something like, let me see, where was I creating it? There was one file, one method. Yeah, this is the one, base name, this, correct. So what I'm doing is get cache key prefix. So I get the model name, so blog underscore slug underscore, and then the slug. So what happens is, I get a key something like blog underscore slug. Yeah, something like that. Thank you, cursor. And then we look for this key in Redis to get the data that we want. Now, the question is why we have this trait? Because when we are talking about individual object being cached, that object needs to be invalidated. When the object key meets its TTL, it will invalidate, which is the very default. Redis does it automatically. But if I want to control the invalidation for certain scenarios, those scenarios can be tackled using the boot methods. So this is the boot for the trait. Now boot cacheable. My trait name is cacheable, so this method will be executed when the trait is invoked, and it will register these. So static created. On created, I have model.cache model. On updated, I have model.cache model again. And on delete, I have model.clear model cache. So let's look at this. Cache model is here. So what I'm doing is I'm creating the cache key and then I'm doing a cache put. Again, the TTL is the same. And while I am explaining it, I think it's a good idea to put this in a config so that overall you have a consistent way of controlling the lifespan of the cache elements if you want to, obviously. So I'm just doing a this load user, I'm getting the entire blog post and I'm pushing it into the cache. So for create and update, I'm doing that. And for delete, I do a cache forget. And because of this, what happens is we have the cached object as well. So this page which we saw was already being cached. We could see that it's a page level cache, and then when I click over here, this is where the object level cache is happening. Now there's one more caveat, and I didn't do that level of caching right now in this video, but I wanted to give you a teaser that let's just imagine this blog post had a little more information as well. For example, it had a sidebar that is dynamic in nature. It has comments below, which is again dynamic in nature, but obviously the content is quite static in nature. So in this situation, how do you handle the caching? How do you have the dynamic content continue to be dynamic, but this thing doesn't change, so I should not be making a query to that? Think about how you can do that, and if you don't get it, comment below and let's see if there are enough comments of people who are not able to understand that. Maybe I'll create a video out of it, but a hint is you need to use something called as fragment caching. Fragment caching allows you to focus on certain areas of the application or the page, and you can bypass certain things. So try that out. And till that point, this is the two very common caching strategies that I use in my application. And this is one great use where I have seen repository pattern comes into picture, because these kind of app service provider logics, right? I can pretty easily look at the environment and say that if my environment is production, go for the Redis blog repository, but if it is production, non-production, so staging or development, go for the file one. So these kind of things are possible, and this is what I wanted to show you in this video, guys. So as I said, caching layer is a very powerful tool. It gives you the ability to get the best performance out of your application, but that needs to be thought through. It needs to be there in your code right from day one. Think about getting the data in cache, retrieving it from cache, rather than putting it as the last item before you deploy your code. Thanks for watching, guys. If you like this video, then do click on the thumbs up icon and don't forget to subscribe to my channel.